Hello. Okay, so this week we're going to handle exception handling and file I/O. The file I/O we're doing is just text-based, and if you can do text-based file I/O, it's pretty straightforward to move on to binary or other formats. They're both chapter 12 of the text. Two topics go well together because often with file I/O you want to do exception handling because of the dreaded file not found error or other errors where you have issues with formatting in a file while you're trying to read it in. Okay, there's only two outcomes. They're both fairly substantial, however. And the notes are short again because we're going to rely on code. All of the code is directly from the Yang. I did not modify the code. I think I made some trivial modifications, but it's the Yang's code. All right. What's the deal with exception handling? Now, when I say exceptions, you can think of errors or fatal errors, anything that would stop the program from executing and cause that big list of error messages that some of you maybe have seen. The idea is to maintain control of the program. So rather than have a situation where the user does something that causes an error and the program crashes, instead you can manage that error, you can handle that error and have some alternative programming that does something to reset the state or set some default values, but allows the program to continue. The bottom line is you're trying to maintain control over the program state. If you have an error, your program can go into an unknown state or an unpredictable state. And that is a problem both in terms of robustness, meaning that the program operates properly or at least operates in all kinds of adverse conditions. So robustness is a qualification or a quality that you have your programs to have. I don't know if you've ever used software that crashes all the time, but as a user, it's frustrating and you end up saying this software sucks and you don't like it anymore. So in terms of selling software to people, you're not going to make any money by selling software that crashes all the time. And the other aspect is security. Hackers intentionally try to get software to go into an unknown or indeterminate state in order to take advantage of it and try to exploit, either to try to access memory or to try to inject their own code into the system. So from robustness and security standpoint, having a well thought out way to manage your exceptions, your errors, is a good thing to do. It's defensive programming. Remember, program defensively. Don't assume everything's going to go well. Even if it should, assume some way that it's not. The typical terminology that we use is try, throw, catch. This is terminology that's used across multiple programming languages. So you'll see try, throw, catch in Java, like you will here. And you'll also see it in Python, and you'll see it in C#. I think you see it in C++ also. It's a pretty common way to describe what's happening. And the idea is try. You try some actions. If something goes wrong, the system will throw an error or throw an exception. You can also choose to create your own exceptions and throw them. And then the catch is another block of code that catches the exception. So if the system throws the exception, your code catches the exception. You tend to specify what kind of exception you're looking for, and you can specify multiple types. So you can have several catch blocks for one try block. Each catch block is going to catch a specific type of error. And the reason you do that is the code that you write to fix the problem might be different based on the kind of error that you saw. So you try something, if an error is thrown, you catch it, and instead of having the program just crash, the control reverts to the catch block, and you can execute your code, and then your software continues on its way. The program continues to execute. What kinds of exceptions do we have? Array index out of bounds exception, file not found exception. These are the common ones. There's many, but these are the common ones. File not found, input mismatch, and null pointer exception. You can, of course, always go to the Oracle help pages or tutorials to find out lists of exceptions. Array index out of bounds is common because it's pretty easy to do the math wrong and end up running off the end of an array or trying to access an array element. Let's say you try to access the negative first element array for some reason. Then you're running off the end of the array. You can run off the other way too. So if we have n elements in an array, we know that the indices are between 0 and n-1. If you ever try to access the nth element, you forgot in your for loop how to terminate it properly, then you'll get an array index out of bounds exception. It seems like that's an easier thing to get in languages like C, the old language C, than in Java, because we can always use array.length as a marker. But you'd be surprised, right? Things do go wrong. File not found exception, pretty self-explanatory. You're looking for a file for input, it's not found. Input mismatch exception is probably the one that is most germane to this course, and the reason is you only need to have one example of try, throw, catch in your project that is not file IO related. So a really common way that students do that is whenever you have the user providing free form input and you try to put in the wrong data type, you would get input mismatch exception. So using try, throw, catch at a place in your project where you allow the user to have free form input, you have a text box that a text field that they're supposed to fill in. That's a really easy way to meet the project requirement. And the other is null pointer exception. This one shows up a lot when students are developing their projects. A null pointer exception means you're trying to do something with an object that you haven't created yet. And you would think, oh, of course I know if I've created that object, but it's not always obvious. So I do see students getting null pointer exception quite a bit in their code. You can't use an object until you create it. And if you remember, the name of the object, you know, when you say that you have some kind of an object and you give it a name and then you say equals new object, remember the name of that object is really the handle or the pointer to the memory space for that object. And if you haven't created the object yet, its default value is null. So that's why you get null pointer exception. You're trying to use the handle to an object that you haven't created yet. You may specify, as I said earlier, what kinds of exceptions you're looking for. So you can have one try block and then maybe two catch blocks, one for an input mismatch exception and one for a null pointer exception, whatever. So you can catch the different types and then perform a different action based on the different types. Why use exceptions? The Liang code, and we're going to focus mostly on the Liang code in the lectures here. Show examples of division by zero. You know, doing division and what happens if you get division by zero. Well, if you do nothing, clearly that's not sufficient. If you ever get division by zero, the program crashes. You may have learned in the past that you should put all of your divisions in a if statement. So if the denominator is not zero, then go ahead and perform the division. Otherwise, don't. Do something else. That actually serves the purpose of the exception handling. What it doesn't give you is a notification. So for example, if you got a 0 because the user actually put a 0 in for the denominator, that's a pretty easy thing to understand. And you can warn the user not to do that. But if it happened because your code actually generated that denominator and you were pretty sure based on your logic that that should never ever happen, but then it does anyway, what that means is there's an embedded logic error. Something's gone wrong in your code. And so using the if then else fixes the problem in terms of the program doesn't crash, but it doesn't necessarily flag you that something went wrong. It doesn't tell the user that something went wrong so that their values may not actually be correct. It doesn't tell the developer that something went wrong, so their logic may not be correct. Now you can put print statements inside the if then else block. And in that sense, you do get some kind of a notification if people are paying attention to it. With the exception handling, you actually get a record of the exceptions that are thrown that are managed by the Java virtual machine. So it's a little more, and we'll see an example of that soon. It's a little more complete in terms of information you might want if you're doing troubleshooting. When? Well, any place a program, in the program where an error could occur. That's everywhere. So there's a fine line, right, between too much and too little. Use it at the places where historically or through your own experience, you found that program errors might pop up. User input is a gimme. You should always validate and verify user input, again, both from a robustness and a security standpoint. File I/O is a gimme. Not just the file not found problem, but once you start reading data from the file, you always presume that that data is in a certain format. But if there's an error in that file, the format is incorrect, your program may crash for no reason. Otherwise, if you use error handling, you can just throw away the bad data, keep the good data. Maybe the file got corrupted. Maybe someone accidentally edited the file and changed the format. Maybe someone accidentally input data incorrectly to begin with. So those are two really easy ones. As a general rule, array usage is a place where you may want to use error checking also, or exception handling also. You can also check for input parameters to your methods, and I've seen students use this as their example in the project file. So for example, I've said all semester that the biggest advantage of one of the biggest advantage of the object-oriented paradigm is this notion that you're protecting your data, right? You have all your attributes are private. Nobody can play with your data. And then you go ahead and create a public setter method, and that allows people to set the values for your data. And that seems counterintuitive because what the heck, now they can change the value of that data, which was something you were trying to protect against. But when you create your own setter, you can also check to make sure that the values that they're trying to set are within range. And I'm saying a user may set this value, but again, it might be another part of a piece of software. It might be some software that somebody else designed and they didn't understand the boundaries that that attribute value should have. It might be software that you designed and you forgot the boundaries, or you have a logical error that puts things out of whack in terms of values. It's not technically an error per se, right? If I have a, my classic airplane flying example, and someone tries to set the altitude to negative 10,000 feet, as long as it's a double, even though it's nonsensical, it's a double value, that's not going to cause an error in the program. You just happen to have an airplane flying at negative 10,000 feet. Well, in your setter method, you can check for that kind of thing. And not only can you check for it and fix it, like in terms of an if then else, you can choose to throw your own error at that point, throw your own exception at that point. Just to let the system know, or to let the user know, or to let the developer know that something went wrong. Okay, great. You got this result from the program, but you shouldn't trust it because we had to take an alternative path to get to the answer. Maybe when airplanes fly at negative 10,000 feet, they end up with more fuel at the end of the flight than when they started, Who knows? That's when. Now, in terms of your project, again, you only need to do this in one case. Just show me you know how to do it. That's all we're asking for in the course. And I recommend free-form text field input, or pick a setter or two where you want to make sure that the value of the attribute, the value that's being set, is within some range. As a general rule, code defensively. When you go out in the real world and you start working for a company, they will have programming guidelines, they will have style guides, and they will have preferences. And so they will tell you, okay, in these situations, this is where we do exception handling. This is where we put in our try, throw, catch blocks. If you feel like they're not doing enough, particularly these days from a security standpoint, if you feel like they're not doing enough, you are allowed to say so, right? You are allowed to recommend that they beef up their defensive coding. All right, so let me pause. Before we go into the code itself, I'm going to pause for questions. And if there's any confusions at this point, if not, we'll move into the code examples. Okay. So again, I'm just using the examples right out of the Liang text. I haven't had time to convert all of their files yet to forms that I like. So the basic form looks like this. The try block here starts on this top block up at line number 19, and you see it's try block, open curly bracket, and then some lines of code, and then close curly bracket, and that is wonderfully consistent with everything Java always does. Blocks of code are always defined by curly brackets. And then the catch is catch, and then in parentheses, the type of thing that they're trying to catch. So in this case, they're only going to catch an arithmetic exception. They're not catching the other forms. So they're only catching arithmetic exception. Now, you can do multiple catch blocks. You might do one for arithmetic exception, and you might do another one for input mismatch, type mismatch errors. And in this case, all they do for their catches, they just print out, hey, we got an exception. And then they don't do anything else because it's a very, very, very simple piece of example code. What happened to the throw? Where does the throw occur? Well, inside that method quotient, all they do is divide number 1 by number 2. And if they get a division by 0 error, that will be the arithmetic exception. So actually that method named quotient is the one that's actually going to throw it. So if the system throws the error, you won't see the word throw in your code. It's just try and catch, and then it's the system itself that's throwing the error. The Java virtual machine will throw the error. If you want to make your own situations where you deliberately force an error to be thrown, an exception to be thrown, you can do that. So that's what the bottom box is showing. It's from another Liang example. That's what the bottom box is showing is, hey, I choose to throw this error, and note the way it's formed, throw new exception. The fact that we use the keyword new is telling you that we're creating an object. So in other words, an exception is an object. If an exception is an object, then it has attributes and methods. So this is showing you two instances in the code examples. The normal try catch block, and then the throwing of the exception. And in this case, they put the try catch block inside of a while loop. And so what they're doing is they're asking for user input. Again, a natural place to use try, throw, catch. They're asking for user input. They need the user to put an integer in. And if the user does not put an integer in, they just keep looping and looping and looping and looping. So without the try catch, if you put a non-integer value in, you'd immediately get a program crash. But instead, you get a type mismatch error, or an input mismatch exception. and then that gets caught. And then you give the user some corrective action, try again, in integer is required. By the way, when you're doing this with your user, don't just say try again. Tell them what they did wrong or tell them what they need to do to fix it. I have had commercial software where I'm trying to do something and it just keeps saying try again. And I'm like, I don't know what to do. So don't make your users hate you. Give them instructions. So you can see there in the code that as long as the user is being stubborn and not inputting an integer, this thing will just keep looping forever. And then eventually when the user stumbles upon an integer, it will go up. Okay, so let's look at code example. We'll do the file stuff on Wednesday. We'll do the exception handling today. And the file stuff is all sample code. All right, so here, if I start with just good old quotient, no exception handling, no error, no checking at all about the denominator. The denominator is allowed to be a negative number. And so let's see here. I just do quotient, enter two integers, 6 and 7. And it says that, they're dividing integers. So 6 divided by 7 is equal to 0 because they truncate, right? Let's do it again. Let's do 15 and 3, and we get 5. Okay. Let's put in a 0, 0 and 8. No problem because the denominator is not 0. Let's switch it around, 8 and 0, and now we have arithmetic exception, division by 0. Trivia for you, if you were using doubles instead of ints and you divided by 0, instead of getting an error, you would get the result of infinity. That's just how Java was designed. It makes sense it actually makes sense with doubles because of round off issues. Let's try something else. This is not at all about the input, the arithmetic exception. They asked for an integer, I put in the letter E, now I get an input mismatch exception. So right away I've got a problem. Again, once we get to the try, throw, catch part, you could choose to catch both the arithmetic exception and the input mismatch exception. If I do this quotient with exception, let's see, I'm going to go to quotient with if. This is basically checking to see if the denominator is 0. So they're checking right here if the denominator is 0. Why they didn't name those numerator and denominator is beyond me, number 1 and number 2. So anyway, if the denominator is not 0, then they'll do the act. Now again, this fixes the problem. This fixes the problem of the program halting with a terminal error, but it does not do so much in terms of record keeping. If you actually wanted to check out, hey, an error was thrown, no error at all would occur here. So you would not be able to do any good, as much tracing into the problem if you found you had a problem somewhere. So this is with if. And so we do that, and I'm not going to mess around much. It's just if we put a 0 in, it says, okay, divisor can't be 0. So it didn't fail, but it also, in this case, wasn't designed to give us corrective action. You can use if then else's, and you can do with corrective action. You can put them inside the do loops or the for or the while loops to make the user keep having more opportunities to provide it. But they don't here. It's just an example. Then they do quotient with method. I'm not going to run this one other than to say all they did here is they put the quotient in the method and still verified, okay, if the denominator is 0, then print out the warning message, exit the system. So actually they do halt the program at that point, and then otherwise return the division. I'm not going to run that. I'm going to run this one with the quotient with exception. And here, it's the same trick. They kept that method, and that's the only reason we talked about the method a minute ago. They kept that method. But now if the denominator is equal to 0, rather than doing, they actually, oh boy, Microsoft Teams is going to help us. They actually throw an exception. And notice they deliberately use the keyword throw. They didn't rely on the Java virtual machine to attempt to do the division and throw its own error. They threw it. Now, once you throw that, no more execution in that block after that. It's going to throw that error immediately back to whoever called it, and then whoever called it will catch the error. Well, where was that done? This was the try, and all they do for the try is they call that method, right? They call the method. And then if that method throws the error back, they'll catch it. And notice they're catching an arithmetic exception, and that's the type of error that they threw. They threw an arithmetic exception. And again, how many different exceptions are there? There's a lot. So here, just from a program design standpoint, you might have wanted to put this whole thing where even the user input is inside the try block, and then you not only would catch arithmetic exception, you could also catch the input mismatch. Two more things to talk about. The chained exception. Notice in this quotient with exception, they called a method, and that method had the capability of throwing an error. If number 2 was equal to 0, it would throw the exception. Well, what if the method that it threw that exception back to couldn't handle the response? It wasn't at the right level of the program to have enough information or visibility or control over other objects to fix this thing. Well, you remember that you normally start out with your start or your main, and then you call a method, which calls a method, which calls a method, which calls a method, right? You can go several layers deep. And what can happen is if you have a method that throws the error, then it throws the exception, it throws it back to the method that called it. And that one, rather than dealing with it, can throw it back and throw it back and throw it back. So that's what this chained exception example is about. It's only 3 layers deep. We have main is going to try to do method 1. And then method 1 is going to try to do method 2. And method 2 is bound to fail because the only thing it does is throw an exception. I mean, this is a remarkably silly, simple example. But what they're showing you is method 2 throws that exception back up to method 1. Method 1 throws the exception back up to main, and then you get a trace of all of the exceptions. That's what's happening here. So if we run this thing, chained exception demo. No. And again, I invite you all to play with these things. And right away, I mean, the whole thing, all it did was give us a problem. Notice it says here, exception info from method 1, exception info from method 2, and that's what's printed out here. Exception info from method 2, exception info from method 1. And it tells us what the lines of code are. So you can get this whole series of issues. And if you'll notice, we do get that automatically from the, we do get this from or look at this, this was, oh wait, in thread main, we had an input mismatch exception. Where was that exception found? It was actually thrown in the scanner. Where in the scanner? In the next int method in the scanner. Well, we don't know anything about the scanner, right? That's code we don't have access to. But it finally does tell us, okay, we had an input mismatch exception. The scanner didn't like what was happening. And then we find out, oh, that was in quotient.java line 9. So you do get this sense of a stack trace automatically, but you can individualize it for your software if you create your own exceptions. And then this last method, this last thing to try is test exception. I think we want that. And again, what they do here is they coerce an error. They coerce an array out of bounds exception. They, up in main, they try to run this sum method where they create an array of integers and all they're going to do is sum up the elements. But then what they do inside of some integer, so there's this sum, there's the method that they create. When they sum it, they go through the array, but instead of doing I strictly less than list.length, they go I less than or equal to list.length, which clearly is going to get you running off the edge of the array. It's one too many array elements. So they're designed this to be an error. And then once they get this error, the exception is thrown. Notice there's no throw statement down here. This is the system itself said, hey, you ran off the edge of the array. You have an array out of bounds exception, and it throws that arrow. Now, since sum was called by main, it gets thrown back to main. Since sum was called right here in this try block, that's where it gets thrown to, and this thing catches the exception. By the way, lazy programmer, they put in a generic exception there rather than the array out of bounds exception. And then they print the stack trace, and that shows you again what's happening in the different phases of the Java virtual machine. These things are so small. These examples, your stack trace is fairly small. They print out, let's see, x.get message, x to string, so that we can take a look at these things. And then they print out in this for loop, trace elements dot length. So in other words, the trace elements are an array of elements inside of the hold on. All right. Inside of the stack trace, and if we take a look at what we see here, it says array index out of bounds exception. What a surprise. And it tells you the value, 5. Let's take a look here. There's array index is 1, 2, 3, 4, 5 elements in it. What are the legal array indices? If you have 5 elements, remember it's going to be 0 through 4. And they're telling you, hey, somebody tried to access number 5. It doesn't exist. Only 0 through 4 exists. And that's in line 24. There it is down here, line 24. And then let's see if we can go through this again. And then they go through and say, this is the trace info obtained from the get stack trace. Right, that's from right here. And all they do is they print out the elements of these of the stack trace, and it tells you these two things. Inside the method sum, there was an exception at line 24, and that came from the method main, where there was the exception of at line 4. So they're telling you what method, what line number, and then what method called that method, what line number, what method called that method, what line number. You can get that information from the longer form, but it's a little uglier. I'm not requiring that you do this stack trace type stuff. This is a little bit beyond the scope of the class. All I'm asking you to do in your project is have at some point a try throw, a try catch. If you want to create your own errors and throw them, that's fine. You would have a try throw catch. As always, I encourage you to play with these and try to break them and change them and see what happens if you omit things or add things. And that's all we need to do. That's all I have for today. So on Wednesday, I want to go over the file IO stuff, but I don't want to start it now because we're going to run out of time soon. So if there's any questions before we go about first about the material. And then are there any questions about the class in general? Okay. All right then, guys. Always good to see you. I'll see you on Wednesday.